Welcome to Get Your FRQ On. This question is from 2007, Form B. It's question 2, and it is calculator active. In the question stem, we have a particle moving along the x-axis, and its velocity v at time t greater than or equal to 0 is given by the function v of t equals sine of the quantity t squared. The graph of v is shown for values of t between 0 and the square root of 5 pi. The position of the particle at time t is x of t, and its position at time t equals 0 is x of 0 equals 5. In part A of this question, we are asked to find the acceleration of the particle at time t equals 3. Since a of t is the derivative of v of t, a of 3 is just v prime of 3. First, a of t is the derivative of sine of t squared, which is going to be 2t times cosine of t squared. This is a calculator active question, so we will use our calculator, although note we don't really have to. We could just plug in 3 for t and leave it in terms of cosine, but let's use our calculators. So a of 3 equals v prime of 3, which is 2 times 3 times the cosine of 3 squared, which is 6 times the cosine of 9, which is negative 5.467. And again, just because it's a calculator active question doesn't mean it's calculator required. If you would have left the answer as 6 times the cosine of 9, that would also have been accepted. In part B of this question, we are asked to find the total distance traveled from time t equals 0 to time t equals 3. The total distance traveled will be the integral from 0 to 3 of the absolute value of v of t dt. And again, this is a calculator active question, so we will use our calculator. The integral from 0 to 3 of the absolute value of v of t dt is the integral from 0 to 3 of the absolute value of sine t squared dt, which is 1.702. In part C of this question, we are asked to find the position of the particle at time t equals 3. The position of the particle can be found by using the equation x of 3 equals x of 0 plus the integral from 0 to 3 of v of t dt. And since this is a calculator active question, we will use our calculator to evaluate the integral. X of 3 equals x of 0 plus the integral from 0 to 3 of v of t dt is 5, plus the integral from 0 to 3 of v of t dt, which is 5.774. In part D of this question, we are asked to consider the interval from 0 to the square root of 5 pi. We are asked for the time t when the particle is farthest to the right and to explain our answer. The particle will be farthest to the right either at an endpoint of the interval or when v of t equals 0 and changes from positive to negative. V of t equals 0 implies that sine of t squared is equal to 0, which implies that t squared is either 0 or pi or 2 pi or 3 pi or 4 pi or 5 pi. And then this implies that t is either 0, square root of pi, square root of 2 pi, square root of 3 pi, square root of 4 pi, or square root of 5 pi. And then note that both requirements are met when t is either the square root of pi, the square root of 3 pi, or the square root of 5 pi. And because this is a calculator active question, we can actually calculate the position of the particle at all 4 of those times using our calculator. X of the square root of pi is 5.895. X of the square root of 3 pi is 5.788. X of the square root of 5 pi is 5.752. And x of 0 is just 5. From this, we can conclude that the particle is farthest to the right at t equals the square root of pi. If you like the AP Calculus free response question solutions and want more of them, don't forget to like the videos, subscribe to the channel, and you can also find me on X at x.com/getyourfrqon.